Hey, what's up, guys? Today we're going to be doing the percent of or increase of change. So we're still talking about proportions, but we're going to be talking a little bit more specifically about percent increase and decrease. So this is going to be the notes that I'm going to use. They're actually on your in your Canvas. So if you have any questions about that, so percent of change. This is going to be a pretty basic formula. So it's going to be change over original equals percent over 100. So change over original equals percent over 100. Okay, so that's going to be how we start off with our notes. Then we've got two different pieces. We've got the percent increase and the percent increase or decrease. Increase means something is going up, and decrease means that something is going down. So let me just give you an example of that. Okay, if something is increasing by a percent, that means that you're going up. So for instance, like stock, if it increases by a percent, or even if you go to the store to buy something, we could say it's a 20% increase because we're running low on that item. Decrease would be like a coupon, a sale, something like that. It's going to be a percent decrease down. So I've got some examples here. We're just going to work through these examples. We're going to talk about each one. Maybe not all of them, but we're going to go through enough that you will feel confident about watching this video and then being able to answer the questions while I'm gone. So, with that being said, let's start with question number one. So we've got 25 to 49. Okay, now first of all, we should ask ourselves, is this a percent increase or a percent decrease? Well, if we're going from a small number to a big number, we know that it's going to be a increase. I'm going to go ahead and write out our formula again. It's going to be change over original equals percentage over 100. Okay, so when I say change, what I'm talking about is what is the difference between 25 and 49? We're finding the difference, and that's subtraction. So we're going to do over here on the side 49 minus 25, 24. So now we're going to have 24, my change, over the original, which is 25, that's what I originally had, is equal to percent over 100. Now I don't know what the percent is. That's what we're looking for. We're trying to figure out what it is. So I'm going to change percent to my variable x. Now we just have a proportion here. So once again, I'm going to look at this, and since I have both of these numbers, I'm going to try to figure out what's the scale factor. What can I multiply this number by to get this number? Well, the answer is 4. So if I multiply 25 by 4, I get 100%. If I turn around and multiply 4 by 4, 24 by 4, I'm sorry, I'll do some side work, I get 96. So what that means, that is a 96% increase. My price increased by 96%. Let's think about that. 25 doubled is 50, so it's pretty close that 96 is almost 100% increase. Okay? Next problem. All right, so again, notes are on there, but it says, Susie purchases a daily planner for $32. The wholesale cost is $25. What was the percent markup? Okay, so we're going to keep our same formula. It's saying percent markup. The word markup means increase in price. So we're marking that price up or raising the price of it. So we're going to take our change, which is we're going to go from 25 to 32. Okay, again, this is an increase, which means that we expect it to be more expensive. And so we're going to take our change, which is the difference between 32 and 25, is 7. So we're going to have 7 over the original, which is 25, is equal to x, or the unknown percent, over 100. Now, once again, we have 25. Again, it's an easy number. So I'm going to multiply 25 by 4. That's my scale factor to get 100. And multiply 7 by 4, which means that x is equal to 28. So what this says, if we're tying it all together, is that they raised the price by 28% to get 32. They raised the price by 28% to get 32. So the markup, or what the store charges that they can make money off of it, was a 28% increase. All right, next one. We've got bottled water costs $1.25 in the vending machine. The price is the markup from the wholesale cost of 20 cents. What is the markup as a percent? So once again, we're still increasing. So we're gonna mark it from our original cost is 20 cents, or 0.2. And we're gonna change that to $1.25. It's a pretty big jump, so be ready for that. Now, we know this is an increase because I'm going from a smaller number to a bigger number, so it's gotta be an increase. The change is going to be $1.25 minus 20 cents. So the change is going to be $1.05 over the original, which is 0.20, is equal to x over 100. Okay, so now I know that we can look at this and we can say, okay, from 0.2 to 100, that's a pretty big jump because the decimals in there. Some of you might feel comfortable doing that, marking off some of the things. I'm going to go ahead and cross multiply and divide though. It's going to take me a little bit longer, but it's going to be a more foolproof plan. So I'm going to do $1.05 times 100. $1.05 times 100. So we're going to have 0, 0, 0, 0, 0, 0, 0, 0, 5, 0, and 1. I'm going to add those up. I've got to put my decimal here. So I end up with 105, which if you think about it makes sense because we're multiplying by 100. If I move my decimal twice, I get that. And then I'm going to have 0.2x. Now from here, we're going to have to divide 105 by my 0.2x, or my coefficient. So just to show how that looks, it's going to be divided by 0.2, divided by 0.2. So x is equal to, again, we'll come over here, 105 divided by 0.2. Now let's just throw some of our math skills back into it. My divisor cannot have a decimal. I've got to move it, which means I've also got to move this decimal here over 1. So now we're going to have 2 dividing into 1,050. Then my decimal goes on the end there. The 2 goes into 1 0 times, goes into 10 5 times. That gives me 0, go down my 5, that's 2, 4, 1. Okay, so let's talk about this. If x equals 525, what does that mean? We know it's a percent. So what that means is they're marking up the cost of this water bottle. Oops, sorry guys, you can't even see my work over there. So sorry about that. By a pretty extreme amount. And so when they mark up that amount, I got 525%. So that means that they took that very cheap price and they marked it up by a ton. And so that's why I went from 20 cents to $1.25. It's a much, much, much more expensive amount. Okay? All right, one more increase, then we'll do some decrease. When Bobby was exercising, his heart rate went from 79 beats per minute, 79 beats per minute, to 98 beats per minute. Okay, once again, this is an increase. Okay, and then it says approximately what was the percent increase. So again, it's going to be change over original, so 98 minus 79 gives me 19. So we're going to have 19 over 79, my original, is equal to x over 100. And again, we don't have the scale factor here, so we're going to have to cross multiply and divide. So 19 times 100 is going to give me 1,900, and then that's going to be equal to 79x. Okay, again, my variable's on this side, so I've got to divide both sides by 79. So over here we're going to have 1,900 divided by 79, 0, 0. I don't know how many times 79 goes into 190, so we'll do 79 times 3. 7, 14, 21, 23, it's too much. So now we'll do 79 times 2. I get 158. Subtract these out. 32. Let's try 79 times 4. So I get 316. So I left off my number here. then I got that 4. So then it would continue to be a decimal. And I'm not gonna go any further just for time purposes, but I know that my X value is gonna be 24 point something. Okay, so that's all of the percent increases. What I wanna do now is I wanna do a couple of the percent decreases. Probably won't do as many just because I feel like it's the same idea, but I do wanna show you a couple of them before I end the video. So percent decrease doesn't change anything, it just changes the wording, which just means that we're going to be dropping instead of increasing. So for instance, let's go from 50 to 45. So notice I'm going from a bigger number to a smaller number. Change is 5, okay, over original is 50, is equal to X over 100. Now guys, this one's pretty simple. We know the scale factor is gonna be times 2 because 50 times 2 is 100, which means to do that. So what that means is that X is going to be 10. So what this means is I'm dropping by 10%. So I'm changing the price of that from 10%. So if we went to the store and a video game was on sale for $45, originally 50, that means it is a 10% discount of that, which 10% of 50 is 5, so that's logical. Okay, another one here. Okay, Carlos used a coupon and paid $7.35 for pizza that normally cost $10.50. Find the percent of the discount. Okay, so this one's gonna look a little bit backwards, so just bear with me on this one. We're still gonna find the change the same way, so I'm gonna do 10.5 minus 7.35. So it's $3.15 is the change. But what I want you to see is this is not the original price. The original price is $10.50 because that was the price before we did the sale, before we used the coupon. So the original price is the type price that we had before we got the discount. So that's gonna be 10.5 is equal to X over 100. Now once again, we're gonna cross multiply and divide. So we're gonna do 3.15 times 100, which I believe is gonna be 315, but let's just confirm it. Yep, 315. And then we're gonna divide that out by our 10.5 here. Okay, so over here I'm gonna do my 315 divided by 10.5. Once again, our divisor cannot be a decimal, so I gotta move that one over. Creating this one, so it's gonna be 105 dividing into 3,150. So 105 goes into 3 0 times, 31 0 times, 315 3 times. And so what that means is that when all this is said and done, he saved 30% on his total price of his meal, or he got a discount of 30%. Okay? I'm gonna go ahead and stop the video here, y'all. That's about 13 and a half minutes. There's 2 more examples, but I think you get it. The real biggest thing is just understanding that original means the original price. So whether we're increasing and making something more expensive, we're using the original price, or if we're decreasing, we're using the price before the coupon was attached to it. Hey, good luck today. I hope you guys have a wonderful weekend. I'll see you guys on Tuesday. Please be good. If you have any questions, send them in to me, but I won't get back to you until I return. Bye, y'all. Be good.